As we review last lecture regarding the one syntax that we call it pin mode and also digital write, now it's better to review some example which help us to slowly start the programming for Arduino board. Uh, this example that today I put for this PPT, you should use the simulator as I saw most of you do the task number 3. Use the simulator Pro Tools and send it for me on Friday lecture. Also, please don't forget that you have one more task, which we call it task number 4, about Arduino free simulator. I give you the table that you should fill it and start to do the programming and also simulating with that. But as the main target of our course is to using the Proto simulator, you can continue the programming and simulating job with the Proto software. Okay, then today we talk regarding the example on some LED and one new syntax that I call it analog write. And this is the whole hardware arrangement that we can have to show an LED as on and off. As you saw, um, in our Ono board, we have some digital pins from pin number 0 to 13, which with the help of them, we are going to specify the mode of digital pins as input and output, which already we just know how to put it as output. Today we will use some output part. Later we work on input and specify the mode as the output, as the input on that. And as I saw in the simulation task, most of you have done this uh, work, means that LED on and off on pin number 13, and you see the program. Then I will try not to speak much more on program because we know, but very brief if I want to talk. First line in the setup part, as we said that in Arduino part, we have two parts of setup and loop. In the setup, first we will specify the mode of our pin, which as we know, the LED we want to put it as output. Then I will specify the pin number and pin mode as output, which it will inform my Arduino board that this specific pin should show something for me. In the next part, which we call it loop, we are going to specify the task for that pin. Then we review the syntax of digital write, which in that will specify the pin and also level or logic. For example, in the first line after the loop, as you see, digital write 13 and high, it shows that pin number 13 should become 1 or high. Then we use the syntax of delay to spend some time, and then digital write again pin number 13, and we make it low with the delay of 1000, which is near to 1 second. But let us more discuss regarding LED and one new maybe part of type of LED that you don't know. For LED, we have one symbol that it's like this as the light emitter diode in electronic, and it has the two part of anode and cathode, which the anode part physically, if you see, it has the longer pin. Most of the people will use different value of resistor here, but initially for the Arduino you can use 100 ohm, but I prefer to use the 1k ohm resistor for that. Please aware that this is the monocolor or one color LEDs. We can have the RGB type as the red, green, and blue, which is compact in one LED. And by giving the voltage to pins, we can have the three different color of them, which people they call it RGB LED. This is the figure which shows how we can use, suppose, LED on pin number 2. Okay. After the resistor, you will put it here, and one pin, the anode one, you should connect it to the Arduino board. Uh, as the figure here shows. But people mainly tell me that how we should how we should know the value for this resistor. This resistor value generally can find by the different value of the resistor, and mainly by the manufacturer data sheets. The voltage to giving to the different color of LEDs are different. Suppose for my red LED, generally I should provide 1.7 till 2.2 volt to turn it on proper. And suppose for the yellow part, 2.1. Then if you want to have the shiny and nice color for your LED, you should work on the resistor, which it can calculate simply by the method that are written here. We know that we have the limitation of 200 milliampere there. And then if we calculate, suppose, by the known voltage of 1.3 or 3.7 that we have here, we can find that 65 ohm is the safer side. But I have some advice that maybe 1 kilo ohm resistor is proper to have some glue. But if you want any specific color, or you can work with different value of resistor. Then in Arduino, 1k resistor is working fine. Please remember that. This program, then we review. I can change this pin, my digital pin, to any of pin number 0 to 13 that it's specified uh, on my Arduino board. And we can see the different uh, pin arrangement in our Arduino board. Then by turning high and low, you can blink the LED which you connect to any digital pins from 0 to 30. And remember that this delay also can be different. Means that there is no fixed value for this. Here we wanted 1 second, then we put it 1000, which is new, it's equal to 1000 millisecond. Here, suppose I put 2000 and then I put 500, means that less number of off and more number of on. That today we have some specific things regarding this part that we will discuss. Okay. Now suppose I have this question. I have 4 of LEDs which are connected to pin number 1, 3, 5, and 7. And now I want to turn them on one by one, something like that. What should I do? Very simple. First, I should specify for my Arduino that um, which pins are output, that as we discussed, we can do it in the setup section. And then in the loop, we will start to turn on and off the LEDs. Simple like that. Suppose digital write one high, it will make one my digital pins one on. Then I have some delay. Then I will turn it off and turn on number 3. And then number 3 will turn off and turn on number 5. Then 5 will turn off, 7 will turn on, and so on. This is some sample to work with some various even output pins. But remember, you can also connect some relay board or some actuator or some motors to work on and off, which I'm going to show you in some video that I should record that video for you with the help of relay board. And you will see that how that simple syntax can do this some nice job. Means maybe you want to turn on and off and lamp, you can simply do it. Maybe you want to turn on and off a motor, you can simply do it. If maybe you want to turn on off any actuator, you can do that with this simple syntax. Okay, then suppose if I want to have more number, means that suppose 1, 2, 3, 4, 5, 6, 7 number of digital output pins. Uh, as I show here, simply again I can put them and specify the Arduino pin number and mode in the setup mode, and also I can use the previous method, or simply I can use one for loop, which in my for loop I can turn on and off randomly any of these LED which connected to it. Then here I teach you two things. One is that using the for loop. Another one is that use the random statement, which is here. With this, you can have the different turn on and off LED, as I suppose connected here for you. And randomly, you can turn them on or off. Means that multiple LED blink we can have, and you can see the performance of them. That is something that we can do it randomly. Suppose if you have uh, some random application. But if you have some specific one to turn them on and you can turn them off, here you can use. Suppose in the second program here, first I will start from digital number 2 to digital number 8, uh, one by one. After that, I'm going to turn them off from backside. It's very nice if you do the simulation for this program, which uh, it's your task, and you are going to do it for task number 5 as the work of this. Then this random statement will help you to select any random pins and turn it on and off. Or if you have the target from specific pins, you can use the second program here. Then here we review one example with random as well as fixed pattern that it shows here. Okay, this is what we think till now, and we want to use for the multiple LED or multiple um, output turn on and off, and we can see the performance of any of them. Regularly, if we had the class, I give you some assignment now to do it, and then I will check that did you learn it. But let us try. If suppose we want to turn on and off the LED number 2 and 3 one by one, what should we do? Think for this question or such questions like that we will talk. Okay, let's continue our to the lecture. Um, as here now, we need some example that I will put some video for you. Follow this part better. Please uh, watch that video, which I will share soon for you to working with LEDs and how it should work. Then in the next part, I want to share you one new syntax, which we call it analog write. And in this analog write, we are going to write some value more than 0 and 1. Okay, but what should be that real value? It's something that we are going to discuss. And before that, we should become clear for some concept. Uh, how a digital device can produce some analog output, we can even see in this figure that by the lights visibility of our LED or brightness of our LED, we can generate the different value for analog output of Arduino. Analog output can be simulated using pulse width modulation or PWM, which we are going to discuss regarding the PWM or pulse width modulation. If you see here, this form of shape, we call it pulse. Here I have two states. State number one, we call it T on, which in T on, as you can see, this is the time that my pulse has the value of 1. The second part of my pulse is the part which we call it T off, which in that if you see here, we call it T off, which in that this is the pulse time, which my value is 0. Okay. If this pulse means high and low have the same time, we can call 50-50. Okay, means that T on and T off are, if they are equal, we can say that it's 50-50 or 50%. Then we expected that the brightness of my LED will have the 50% of brightness. But if my on time is greater than off time, or vice versa, my on time is less than off time, you will see that my brightness will be different. Suppose if my on time is more, it's obvious that my LED will have more time to glow or more time to show and less time to off. And if my on time is less, my LED has more time to show and less time to off. Okay. But this concept people calls pulse width modulation or PWM, which has the ratio and showing the ratio of time which you are on divided by total time. Okay. There is one formula which shows that the on time and during the whole time multiplied by 5 will show us the voltage. Okay. And in PWM, you are working on this average voltage. Okay. We suppose in previous uh, example that we have 75 and 25, the output voltage is equal to 3.75. And in 50/50, it's equal to 2.5. And it's 2080 is equal to 1 more. Fixed length and things that you see we have here. This length is fixed. Just the percentage of off time and percentage of on time is this shape and this voltage. They call it PWM, which is very useful in controlling the DC motors or any type of motor. I can tell you, this is one of the famous method to control the motors. Okay, but how I can generate this pulse for myself in Arduino board? I need the syntax, which they call it analog write. Analog write value, or they call it PW wave generation to a pin, can be used to light a LED at varying brightness or drive the motor at various speed. Suppose in the DC motors, if you give 5 volt, it will move fast, and if you give 2 volts, it has the less speed. 1 volt, it has less speeds until then. PWM is exactly based on that. Based on this PWM value, you can have the variation of speed. And after a call to this statement, which we call it analog write, this pin will generate some steady rectangular wave of specified duty cycle until the next call to the analog write or call to the digital write or any other statement. Then first we learn that if we want to generate the PWM, we should use this statement. Second things that you should remember that PWM frequency on different Arduino boards are vary. Suppose if I have the Uno or Nano or Mini Arduino board, my PWM pins are different. They are 3, 5, 6, 9, 10, and 11, which is specified directly on the board. But remember the frequency of PWM, which is 490 hertz for rest of the pin. And just for pin number 5 and 6, this is 980 hertz. Okay. For mega, suppose we have 490, and for pin number 4 and 8, this is 980. It means that if you have some specific application for the PWM pins, you can use the pin number 5 and 6 and or 5 and 13 on mega. And suppose for Leonardo, for 0 DUI 101, which this table is specifically made for Arduino board. Once more, we saw our Arduino Uno board. You see that for the PWM pin, they put this sign, which is specific, and it shows that just this pin has the ability to generate the PWM pin, or we can use the analog write pins for them. Okay, let us continue. Then the analog write Arduino command is used to update the state of analog pins and also used to address the PWM pins on the board. As the PW pins are 8-bit pins, then this value can be up to 255. Means it can start from 0 volt to 255, which is equal to 5 volt. And the duty cycle is described as the amount of time the signal switch between on and off condition. It's mainly written in percentage, and if the signal remains turned on, half of the total duty cycle of off in another half, then the duty cycle will be 50%, as the concept that we review, that on and off time, which when they are equal. And the analog right comes handy when you have planned to control the motor speed or the intensity of the LED lamps. The value you write on PW pins will control the speed. For example, if you intend to turn the motor at full speed, you will set the value of 255. For example, the maximum value it can handle that will ultimately run the motor at full speed. Here I show some duty cycle wave and value, which again for this part also, we will have one specific video that you can see and enjoy the performance of analog write command on Arduino board. Okay, now we understand that to do this nice job, we need the syntax of analog write. And in this analog write, we have two parts. One is pin and another one is value, which this value is limited between 0 to 255, and pin is limited to the specified pin. Suppose, as I show for you here, pin number 3, pin number 5, pin number 6, pin number 9, 10, 11. These are the pins that you can generate the PWM for them and set the output to LED proportional to the value read from the potentiometer. Suppose we will see this application later. Okay, very simple example I can show here. Suppose here in line number 1, I specified the pin which my LED is connected to that, and then the analog pin which is number uh, 13, and some value like that. What I want that just you read this example. Now I didn't teach you two statement of analog write. Sorry, analog read. Okay, this we will discuss after 2-3 lecture, not now. But what is the performance of this example is that I'm reading some value from my analog and then generate some another analog value based on that. We will test this program, but if we want to do it maybe better, first let me give you one warning or notes on using the PWM, then we will see the sample. So please remember that PW output which generates on pin number 5 and 6 will have the higher than expected duty cycle, which we discussed before. And this is because of millis and delay function which we have. And this will be noticed that mostly on low duty cycle, for example, 0 and 10, and results of 0 not fully turning off the output of pin number 5 and 6 means that remember that the PWM number that you should put on pin number 5 and 6 and how you will do with this. Okay, but how we should use this uh, analog write commands? It's very simple. You should just use this analog write, pin number, and the duty cycle that you want. But how we should calculate these numbers? Suppose how we should know that 50% is equal to 2, 1, 2, 8. It's very simple. You should just divide the 255 by 2. and then take the ratio. Suppose 20% of the value of 255 is equal to 64 that you can put it here. It's also very simple. Okay. Here, as the next example, what I have done, I connect one LED to pin number 10. And in pin number 10, um, I generate the different value of PWM, which in that, for first one, I will do it with number of 50. And another one is 255. Means here it's near to 50%, and here it's near to 100% of LED, and we have the different light background from this LED. Okay, as the task 5, I want that you test and run all the example which I put here in this PPT in simulator and send the screenshots from your simulator as well as IDE. Okay, this is something that till next lecture we should have. Let me see that can we have some movie for today or no. Okay, then once more I will share the task in our DinkTalk group as well as in our AJM lecture. Meanwhile, I'm trying to see that if we can see some application of some Arduino boards, which may be helpful for you to follow the lectures that we have, and will help you maybe to have the better concept regarding the um, Arduino application and maybe the work that we have. Please remember or keep it in your mind that Arduino has various applications, and people will work with that in different um, project even, and in their project maybe um, they use very simple syntax as the nature of Arduino, but what you will see the one great performance for the work that they have done. I'm searching for one nice clip now for you that in that maybe some good performance of, yes, I found it, some good performance of Arduino we can see, and you also can be familiar with the performance of Arduino board. Okay, let me share it once more for you, and then we can maybe okay, let me first check that can you see, and then we will continue. Okay, we continue. This is the first job that people have done with the help of Arduino board. As you can see, this is the tablets or any mobile. And then with the same commands that we have done today, digital out, you can work with Arduino. That is suppose project number 10. Project number 9, which this is something like a surgical arm that people will made it with the help of Arduino. And here you can see with the performance of another joystick that they are using some jobs for some nice prototype work with the Arduino. See, first it's train it, then it will go and repeat the job. It can be, suppose, the one part of one industry which you can use. Project number 8 is the stepper motors which you have inside of your uh, Arduino board, and now you don't have sound, but it can generate the sound. I will share these uh, again in the practical section. Maybe we'll see. Suppose another project that we can do with Arduino with the same syntax that today we learn is working with Rubik cube. That here they can tune it and work with that. Number 6, suppose, can be the secret not detecting lock that these people is going to put one Arduino exactly on a board there, and then uh, it can protect the door and see that who is knocking the door, something like that. Let us see the performance of his circuits. Project number 5 can be making the sound with quick button. Here you don't have the sound. I don't know. Okay, project number 4 uh, can be time machine glove, something like that. That with the help of that, they are going to give the command by hand. This is not magic, it's very simple. With the same statement that even today I teach you, you can turn it on and off, something like that. Project number 3 maybe can be something like gimbal or PID control, like that, which they are going to tune the ball exactly between the uh, arms of this. It's very nice, as you can see here. The ball will not fall. Project number 2 can be the chess game that you can work with Arduino board, and you will see that Arduino will move the another parts like that. Hmm? Funny thing is that till this simple syntax that I teach you till today, you can do all these jobs. All of them is based on these 3, and maybe the first one using these robots, Wall-E robots.
What's your name? Hands up.
It will speak to robots, say that hands up, hands down, something like that. Recognize to the was that was the port that people will use. Okay, that was 10 nice project that I found for you. then you can see that Arduino is great. You can do lots of job with it. And funny thing is that as I analyze the program in these videos using the syntax that I teach you till now means that with these three simple syntax, you can do some great job like that. Let us see one performance of the program that we have. Suppose LED on and off, uh, four LED on and off that today we see the program. I want that you also uh, please do it with simulator and send me the screenshot of for that. And one more arrangement, suppose 2 by 2 LED glowing, which is also uh, a simple job as you see. Just you should specify the digital mode pin and also turn it on and off. Uh, Today, what we have done, we review the board digital in and digital out statement. We just work on digital out, and after that we the analog write we review, pin mode also we review. Then for next we are going for some other nice part of the Arduino job.